Hey Ramblers, this video covers chapter 8.3 in our textbook, and we learn 3 ways to prove that triangles are similar by different methods. Now in the previous video we talked about similar polygons, and you'll recall that that means that the angles are all congruent and the sides are all proportional. That is to say, if we compared each corresponding side of one polygon to the side in the other polygon, the ratio would be the same. So tonight we're going to learn 3 different ways to prove triangles congruent: angle, angle, side for similarity, and side for similarity. Okay, please take careful notes and I hope this helps. Okay, there are 3 methods of proving 2 triangles similar, and we'll learn all 3 of them. The first one is presented as a postulate, so there is no proof, and it's stated rather simply as: if there exists a correspondence between the vertices of 2 triangles such that the 3 angles of one triangle are congruent to the corresponding angles of the other, then the triangles are similar. Okay, there's really nothing simple about that at all. So we just refer to that postulate as AAA. But you'll recall from chapter 7 that if we knew that we had 2 angles in one triangle congruent to 2 angles in another, then by no choice all 3 were congruent. So the fact of the matter is, we never use AAA. We only use AA, or what's called angle-angle. And that says if there exists a correspondence between the vertices of 2 triangles such that 2 angles of one triangle are congruent to 2 angles of the other, then the triangles are similar. But you'll just refer to that as AA. Okay, well, that's presented in our book without a proof also. And let's take a look at how that might look in an example. If you were given this figure and told that segment AD is parallel to segment DE, could you prove that the 2 triangles ABC and DEC were similar? Now, maybe even more than in the first semester, the order of the angles is very important, because we're trying to line up 2 angles in one triangle congruent to 2 angles in the other triangle so that we can use AA and prove the similarity. So I am really after anything that would indicate angle A as congruent to angle D, because those 2 come first. I would like to be able to show angle B congruent to angle E, or DEC. And of course, keep in mind that I have angle C as a reflexive angle in both triangles. Nevertheless, in this proof, I'm not going to use that, though that would have been a good idea. The proof will look something like this. I take my givens, and then in step 2 and 3, I have my congruent angles, so that I can conclude in step 4 that the 2 triangles are similar by angle-angle. All right, let's move on to 2 other methods: side for similarity and side for similarity. Observe these 2 triangles, ABC and XYZ, for a moment. And you'll notice that they have the same shape, though they're clearly not the same size. That would be what we mean when we say that 2 triangles are similar. But first, before proving it, we'd have to make sure. So we would take a look and measure the length of AB and XY. And you can see that 4.08 is twice 2.04. If we looked at that ratio, it is 2 to 1. Then we could look at the length of AC and XZ and look at that ratio and see that that's also 2 to 1. Finally, we could compare the lengths of BC and YZ in a ratio and see that that's also 2 to 1. Well, that would be enough to prove the 2 triangles similar by side for similarity. Now, what I've just shown you is not a proof. The book presents side without a proof. I'm just showing you what they mean by side. So let's take a look at the entire theorem, though we will only ever refer to it as SSS with that little squiggle, side for similarity. So if there exists a correspondence between the vertices of 2 triangles such that the ratios of the measures of the corresponding sides are equal, which is just what we saw. These three ratios of the corresponding sides were all equal. Then the triangles are similar. And we would simply write, as a reason in a proof, SSS for similarity. Okay, let's take a look then at a different proof and another method. Not a different proof, but another method of proving triangles similar. Suppose we didn't know the measures of BC, but we did know the angle measurement in A and angle X, and we saw that they were congruent. This would be the third and final means of proving that two triangles were similar. And this would be side angle side for similarity. With side angle side, we're required to show that the ratios of the measures of two pairs of corresponding sides are equal, as they are here. So AB to XY and AC to XZ are equal, and the angle between those sides are equal. So proportional sides, congruent angles, means that the triangles are similar by side angle side for similarity. Once again, this is not a proof. I'm just showing you what it is, and we will always ever write it as SAS with this little similarity squiggle. Okay, make sure that all this is in your notes. These are the three methods. They're very important. We'll be using them frequently throughout this chapter and for the rest of the semester. I hope this video helped, and thanks again for watching.